Horizontal transformations. Let's look at them a slightly different way. So what I have here is the function f of x equals x squared. And what I like to point out to you is that as we transform, right now I have this particular point here, 2, 4. As we do a horizontal shift, what I want you to notice is that the y is not changing, but the x is changing. So keep that in mind. It's going to be very important. Y doesn't change, but x does. So for example, if I come over here to this function, I'm going to transform it. I'm going to say 1 here. So when I graph it, what's happened? Well, I have, again, you can think of this as f of x minus subtract a negative 1, and it looks like the graph has shifted 1 unit to the left. What has happened to this point right here, this 2, 4? Well, the point 2, 4 right now is 1, 4. So that point that used to be here has now moved 1 to the left. But you'll notice again that what's changing is my x, not my y. If I do it again, I have moved that point that used to be here at 2, 4, and then now it looks like it's at negative 1, 4. So it now resides here at negative 1, 4. That's where it went. Again, the x has changed, but not the y. So here's a different way of approaching transformations. Now this is, again, pretty straightforward with a graph. You can see it visually. But what happens when you're not given the graph, you're just given coordinates like this. So hang on. F of x equals x squared. And I know that f of 2 is equal to 4. So that gives us the order pair 2, 4. Great. Now, go ahead and, again, there's going to be a different perspective on transformation. So I got 2 gives me 4. What happens if I do this? X plus 1. Where does 2, 4 go? As we mentioned, and you saw in the graph, y doesn't go anywhere. So the value 4 stays right here. So here's a different way of thinking about this. 2 in the original one gave you 4. You're going to be entering a value right here. So you know that 2 gives me 4, but when you enter a value here, you're going to add 1. So think of it this way. What number do I need to put right here so that when I add 1 to it, I get 2? I know that 2 gives me 4. Well, the answer is 1. When I enter 1 in here, 1 plus 1 is a 2. And then the function gives me the 4 back out. Let's consider that. Fx plus 1. Hang on. So now we're back here, and we can see that indeed 2, 4 was here. When I do the function f of x plus 1, now that point goes to 1, 4. Okay, so if I go back, let me get the other one. If you think about it, here's the way it will look now. This function now is x plus 1 squared. That's what it really is. So what I'm saying is, if I enter a 1, watch. I put a 1 here, and indeed, that gives me 2. 2 squared is the 4. But what I'm entering is a 1. 1 gives me the 4. Here in the past, if I would have entered f of 2, that produces a 4. So this is why the vertical, the y, is not changing. What's changing is the x. But another way of thinking about it is, what value do I need to enter in order for me to get that same output? Okay, let's do another one. let's do this one. F of x plus 4. Okay, so what happens here is I'm adding 4. The output was 4. And again, same question, what do I need to enter here to get myself that 4 back out? But I know that it's the 2 that gives me the 4. So the answer seems to be I need a positive 2. If I enter negative 2 here, it should produce that 4 again, right? So the way it looks like now, let's actually do the calculation. Fx plus 4 is nothing more than x plus 4 squared. So now if I come over here, boy, this is kind of messy. Sorry about that. F of negative 2 plus 4. Come over here, negative 2 plus 4 squared. That gives me 2 squared. And of course, that gives me 4. Okay, so that is another way of looking at a horizontal transformation. Just ask yourself, what x value do I need to get me that old x value? So what do I need to enter into this new function so that this part, this x plus 4, lands me to the old value that produced the same y value. So hopefully that makes viewing this or thinking about this a little easier. But wait, there's more. I want to give you one more observation that you need. So that seems pretty clear. I'm not sure you can follow this. But sometimes you're given questions, and why is it not this simple? The answer is magic. No, not real magic, just sleight of hands, right? The real magic that we do. So what will happen in the future is that often you don't get to see this portion. Instead, this will get redefined as a new function. So once we do our transformation, this will become, let's say, g of x. And all of a sudden, the part that we're changing disappears as far as this function notation. It's completely gone. But now that you're starting to play with transformations, you kind of see how this works. So for example, if I'm giving you g of x is equal to square root of x minus 5, all of a sudden, again, notice the actual transformation piece is gone. But the way I can think about it is that, hey, here's a parent function. It's square root of x. Notice I changed the function notation. And what's happened here, it looks like, that I replaced the x with x minus 5. And all of a sudden, I've renamed this whole thing. Instead of calling it h of x minus 5, I've just said, look, this is now a new function called g of x. And that's all that's happening. It's up to you to recognize the parent function and the transformed function using the parent function. And that's really it.